Hello dear viewers, welcome to this video. Today I am going to show you how we can use Mitsubishi Q series PLC analog input for industrial process parameter monitoring and control. Throughout this video, you will learn the step-by-step procedure to work with the PLC analog input. PLC analog input is used to process continuous signals comes from the sensor or transmitter which measures the continuous process parameter like temperature, pressure, flow of any media. To make you understand how to work with the PLC analog input, we will make a project for monitoring temperature of liquid using Mitsubishi Q series PLC analog input. And to complete this task, we will complete the following working steps. First, select an appropriate sensor and transmitter which can measure the temperature and makes a suitable signal that may be fed to PLC analog input. We will use a PT100 temperature sensor which has temperature measuring range from -200 to 850 degrees centigrade and a temperature transmitter which have been configured as measuring range from 0 to 100 degrees centigrade. Perform a proper hardware connection for analog input with the sensor and transmitter. Hardware arrangement for sensor and transmitter with the PLC analog input have been done according to this circuit diagram. Finally, perform a proper configuration for Q series PLC analog input and make a PLC ladder diagram to find the real temperature value using Mitsubishi PLC programming software GXOX2. The PLC we are using Mitsubishi Q series modular type PLC which CPU model is Q0U3DE. There have been defined input-output modules that can be used with the Q series CPU. For using analog input, we will use analog input module which model is Q64AD that has 4 analog inputs. For any sensor or transmitter analog signal processing, the analog input module is used. Using an arrangement of temperature sensor, a temperature transmitter and Q series PLC, we will measure the temperature of liquid and monitor this temperature by creating PLC ladder diagram. Take a look at the circuit diagram for hardware connection of sensor and transmitter with the PLC analog input. Suppose there exists a tank which contains liquid and we want to measure the temperature of liquid in a range from 0 to 100 degrees centigrade. Here the temperature sensor PT100 have been set with the tank for sensing the temperature of liquid. The PT100 temperature sensor can measure temperature within a range from -200 to 850 degrees centigrade. But we want to measure the liquid temperature in the range from 0 to 100 degrees centigrade. As our desired temperature measuring range for liquid is 0 to 100 degrees centigrade, for mapping the PT100 temperature range to 0 to 100 degrees centigrade, a temperature transmitter have been used with the PT100 temperature sensor and this transmitter has been calibrated as 0 to 100 degrees centigrade. So this transmitter makes a signal of 4 to 20 milliampere with proportional to liquid temperature range 0 to 100 degrees centigrade. In addition to this transmitter output, a 250 ohm resistor have been connected in series with the transmitter output circuit. So we will get a 1 to 5 volt DC signal across the 250 ohm resistor which can be taken as the analog input signal for the PLC. Now to feed this 1 to 5 volt DC signal to PLC analog input, take a look at the analog input module which have 4 number of analog input or channel, for each of which there are 3 connection terminals. If the signal comes from the sensor or transmitter is voltage signal, the V plus and V minus will be used for the connection. If signal comes from the sensor or transmitter is current signal, the terminal I plus and V minus will be used for connection with the sensor or transmitter. As we have considered voltage signal to feed the PLC analog input, connect the terminal across the 250 ohm resistor to V plus and V minus terminals of the first analog input of analog input module Q64AD. Now let us see what happens when the analog signal from sensor or transmitter is applied to the PLC analog input and how this signal is processed in the analog input module. In the analog input module, there is an analog to digital converter for each of 4 analog input. When the analog signal is applied to the analog input, the AD converter converts this analog signal to a range of digital value which is stored in the buffer memory of the input module. Look at the performance specification sheet for analog input module. Analog input accepts voltage or current signal at different range and the conversion of digital values take at normal or high resolution mode. You can select the type of signal and corresponding resolution depending on your application. For temperature measuring, our desired signal is 1 to 5 volt DC and resolution is 0 to 4000, and we will select this during analog input configuration. So, if the sensor measures the temperature of liquid and corresponding transmitter output signal is applied to analog input, we will find the corresponding digital value from the buffer memory of input module with respect to instant temperature value. Now we have to make PLC program which will read this digital value from the buffer memory and convert again this digital value to actual temperature value. For analog input configuration and programming, we will use GXORX2 program software. So let's proceed to work with the GXORX2 program software. For PLC programming, go for GXORX2 programming software in the desktop window and double click to open this software. You will find this kind of window here. First of all, you have to select new project. For PLC programming, the PLC we are using Mitsubishi Q series PLC. So select the series of the PLC Q CPU and the type is Q03UDE. The language we are using the ladder language. After selecting this, click on the OK button to finish. A new project for creating PLC program have been opened. From the navigation of the project, go for parameter and click on the PLC parameter to open the dialog box for Q parameter setting. Now go for program tab and insert the main program. After that, go for input output assignment. Here we have to add the IO module that we are using with the Q series CPU. As we are working with the analog input module, so we have to add this analog input module. Now click on the new module. Here select the module type as analog module and the model of the analog module we are using Q64AD. So select Q64AD as module name. As this analog module have been set on the slot number 2 of the base, so select 2 as the mounted slot number. Note that the start XY address have been automatically set as 20 hexadecimal address. Now click on the OK button to finish setup for the analog input module. Now click on the In button to finish setup for the parameter setting. From the navigation panel, go for the intelligent function module. Here you will find the model of the analog module that we have already added from the PLC parameter settings. Now select the switch settings. The dialog box for switch settings have been appeared here. Here you have to set the number of the channel of the analog module that have been connected to the transmitter output and the signal range that comes from the transmitter output. As we have connected the transmitter output to the first analog input of the analog module and the signal range comes from the transmitter output is 1 to 5 volt DC. So select the input range as 1 to 5 volt DC for the channel number 1. Set the resolution mode setting as normal resolution mode. This will select the AD converter output range as 0 to 4000 digital value, as only one analog input of the analog module have been used here. Leave the settings for other channels as default. Now click on the OK button to finish the switch settings. Go for parameter setting dialog box. Here you have to set the function for analog to digital conversion of each channel, enable or disable. By default, the functions for each channel have been set to enable. You can set the conversion function for this channel as enable or disable depending on your requirements. As we have used only one input of the analog module for transmitter output conversion, set the conversion function for channel as enable and leave the function for other channel as default. Now close this window and go for auto refresh setting. As we know that the PLC analog module has buffer memory for storing analog to digital conversion data. So after conversion from analog to digital value, this value is stored in the buffer memory of the analog module. For analog input programming, this data needs to be transferred from the buffer memory to the PLC CPU memory. From the auto refresh setting, you can define the PLC CPU memory to which this data will be transferred, and using this PLC CPU memory you can create the ladder program for further processing of the analog input value. So put the memory as D10 for channel 1, leave the memory for other channels as blank, as we did not use these channels in the hardware connection. After completing auto refresh setting, close this auto refresh window. Now go for creating ladder program which will convert the digital value of buffer memory register to real-time temperature value. We have already come to know that the analog signal comes from the transmitter output, is converted to digital value and is stored in the buffer memory register of analog module. When we have declared the data memory register as T10 from the auto refresh setting, the digital converted value of buffer register is finally transferred to the CPU data register D10. We have configured the temperature transmitter to have its range from 0 to 100 degrees centigrade. So when the temperature of liquid is 0 degrees centigrade, the analog input signal is on volt and the data memory register D10 gets the converted digital value as 0. If the temperature of the liquid is 100 degrees centigrade, the analog signal is 5 volt and the data register D10 gets the converted digital value as 4000. So all time we get the digital value from the data register D10 is actually a 12-bit converted digital value which comes from the conversion of analog signal applied to input of the analog module. First of all, use a move function to transfer the digital value of D10 data register to another register D100. To get the real-time temperature value from the digital value of D100 data register, we have to scale again the D100 data register value range to sensor temperature measuring range of 0 to 100 degrees centigrade. This can be done by multiplying the D100 data register value by a multiplying factor found from the result of 100 divided 4000. To get the multiplying factor, use a division function in the next line which will divide the 100 by 4000 and put the result in the another data register D200. The resultant value of the data register D200 will be used as multiplying factor in the next line of programming, and the data type for this multiplying factor is real or floating type. In the next line, use a multiplying function which will multiply the value of D100 data register by the multiplying factor which comes from the value of D200 and put the result in the another data register D300. So we'll get the actual temperature value from the data register D300. The program is almost done. After completing the downloading procedure, enable the monitoring option and we'll see how does the program works. Using the monitoring function, if we look at the working procedure for PLC analog input program, we will find how the analog input signal are getting converted to digital values inside the data register D10. To scale the transmitter analog signal to temperature measuring range 0 to 100 degrees centigrade, the digital value of D10 data register are then getting multiplied by the multiplying factor of D200 data register value, and finally the result of multiplication are getting stored in the D300 data register from which we are getting the actual temperature value. If we look at the display of temperature transmitter, we will see that it is showing the real-time temperature of the liquid, which is almost same as the temperature value found from the processing of analog signal done by the PLC. So this is how we can program for analog input signal for the Mitsubishi Q series PLC. If you find this video helpful for you, please like, share and comment on this video, and don't forget to subscribe this channel.